Hello everyone, this is the 19th session of the Advances in Food Analysis, and the topic which we'll be covering today is the overview of thin layer chromatography. Okay, so talking about the introduction of thin layer chromatography, it is a chromatographic technique used to separate mixtures. Chromatography was discovered by M. Twist. The thin layer chromatography is performed on a sheet of glass, plastic or aluminium foil which is coated with a thin layer of adsorbent material, usually silica gel, aluminum oxide or cellulose, which can be called as blotted paper. This layer of adsorbent is known as stationary phase. After the sample has been applied on the plate, the solvent or the solvent mixture known as a mobile phase is drawn up by the plate via capillary action. Because different analytes ascend the thin layer chromatography plates at different rates, separation is achieved. Thin layer chromatography can be used to monitor the progress of a reaction, identify compounds present in a given substance, determine the purity of a substance. Separation of the compounds is based on the composition of the solute and the mobile phase for binding the places on the stationary phase. For instance, if normal phase silica gel is used as a stationary phase, it can be considered polar. Given two compounds which differ in polarity, the more polar compound has a stronger interaction with the silica and is therefore more capable to dispel the mobile phase from the binding places. Consequently, the less polar compounds moves higher up the plate, resulting in the higher radio frequency value. If the mobile phase is changed to a more polar solvent or mixture of solvents, it is more capable of dispelling solutes from the silica binding places and all compounds on the TLC plate, which will move higher in the plate. Practically, this means that if you use a mixture of ethyl acetate and heptane as a mobile phase, adding more ethyl acetate results in higher RF values for all compounds on the TLC plate. Changing the polarity of the mobile phase will normally not result in reversed order of running of the compounds on the thin layer chromatography plate. The principle of TLC. Now, what is the principle of TLC? Thin layer chromatography uses a thin glass plate coated with either aluminum oxide or silica gel as a solid phase. The mobile phase is a solvent chosen according to the properties of the components in the mixture. The principle of a thin layer chromatography is the distribution of a compound between the solid fixed phase, that is a thin layer applied to a glass or plastic plate, and a liquid mobile phase, that is a eluting solvent that is moving over the solid phase. A small amount of a compound or a mixture is applied to a starting point just above the bottom of the thin layer chromatography plate. The plate is then developed in the developing chamber that has a shallow pool of solvent just below the below the level at which the sample was applied. The solvent is drawn up through the particles on the plate through the capillary action, and as the solvent moves over the mixture, each compound will either remain with the solid phase or dissolve in the solvent and move to the plate. Whether the compound moves up the plate or stays behind depends on the physical properties of that individual compound, and thus depends on the molecular structure, especially functional groups. The solubility rule, like dissolves like, is followed here. The more similar the physical properties of the compound to the mobile phase, the longer it will stay in the mobile phase. The mobile phase will carry the more suitable compounds the further up the TLC plate. The compounds that are less soluble in the mobile phase and have a higher affinity to the particles on the TLC plate will stay behind. RF values. The behavior of the individual component in thin layer chromatography is characterized by the quantity known as RF and is expressed as a decimal fraction. The RF is calculated by dividing the distance the compound travelled from the original position by the distance the solvent travelled from the original position. So RF is the distance of center of spot from starting point upon the distance of solvent from the starting point. The RF value is a constant for each component only under identical experimental conditions. It depends upon the number of factors as nature of adsorbent, the mobile phase, the temperature, the thickness of layer, the developing tank, the mass of sample, the chromatographic technique. Plate preparation. Now, how will we prepare the thin layer chromatographic plates? Thin layer chromatography plates are usually commercially available with a standard particle size ranging to improve reproducibility. They are prepared by mixing the adsorbent such as silica gel with a small amount of inert binder like chemical sulfate, that is called as gypsum, and water. This mixture is spread as a thick slurry on the unreactive carrier sheet, usually glass, thick aluminum foil or plastic. The resultant plate is dried and activated by heating in an oven for 30 minutes at 110 degrees Celsius. The thickness of the adsorbent layer is typically around 0.1 to 0.25 mm for analytical purposes and around 0.5 to 2 mm for preparative thin layer chromatography. Capillary spotters. Place a melting point capillary and in the dark blue plate of the Bunsen burner flame. Hold it there until it softens and starts to sag. Quickly remove the capillary from the flame and pull on the both ends to about 2 to 3 times its original length. If you pull the capillary inside the flame, you will have a piece of art but not a good spotter. Allow the capillary to cool down and then break it in the middle. Make sure to break off the closed end on one of them. Spotting the flame. The thin end of the spotter is placed in the dilute solution. The solution will rise up the capillary, touch the plate briefly at the start line, allow the solvent to evaporate the spot at the same place again. This way you will get a concentrated and small spot. Try to avoid spotting too much material because this will deteriorate the quality and the separation considerably. The spot should be far enough away from the edges and from each other as well. If possible, you should spot the compound or mixture together with the starting material and possible intermediates on the plate. The development of solvent. The choice of the suitable solvent depends upon the nature of substance and adsorbent used on the plate. A development solution such as should be used such as do not react chemically with the substance in the mixture under examination. Carcinogenic solvents or environmentally dangerous solvents should be avoided. Solvent systems range from non-polar to polar solvents. Non-polar solvents are generally used as high polar solvents cause the adsorption of any component of the solvent mixture. Mobile phase. For silica gel chromatography, the mobile phase is an organic solvent or a mixture of organic solvents. As the mobile phase moves past the surface of the silica gel, it transports the analyte past the particles of the stationary phase. However, the analyte molecules are only free to move with the solvent if they are not bound to the surface of the silica gel. Thus, the fraction of the time that the analyte is bound to the surface of the silica gel relative on the time it spent in solution determines the retention factor of the analyte. That's all for this session. Thank you.